Welcome to Chapter 4. Let me write that up here. Chapter 4, which is graph theory. And so I wanted to give you a quick introduction to this chapter. And so what we're going to do in Chapter 4, graph theory, is actually three main things. Here's the first thing. Let me jump down to, this question will work right here. See what it says? Make this a little bigger. Find the shortest path from vertex A to vertex L, from here to here. So notice that there's numbers on each of these paths. This is how many, let's say, miles it is from city to city. So if you got all these different numbers, that tells us how many miles from point to point. Maybe those points are cities. So for example, if you're trying to get from location A to location L, you want to do it in the cheapest, in the shortest way possible. So this is very useful information. This is the kind of thing that people who program the algorithms that give us directions on our cell phones, those kind of Google Maps and things like that, they help calculate the shortest distance between 2 points, the route to take to make the shortest distance between 2 points. Very, very useful for companies that are trying to deliver items from one location to the other or move people from one location to the other. It saves them a lot of money if they can find a shorter path in which to do something. So very practical question used today in our world, and mathematics helps us figure out the answer. So how do we get from A to L in the shortest route? Maybe this way, and then maybe that way, and maybe this way, that way, maybe. I'm not sure. How about on number 3 here? Let's look at another one. A to L. What's the shortest path? Well, we shouldn't just guess around. There's actually a whole method, steps you go through to make sure you've got the shortest path. I just guessed around on that last one. You want to make sure when you do homework, and especially when you take an exam, that you're sure you've got the shortest path. So we'll talk about that's the first thing, and that's your first question in the video quiz. The first idea in this chapter is the shortest path between 2 points, the shortest path. Okay, now the second issue we're going to look at is something called Euler circuits. That, I know that word looks like Euler, but it's a famous mathematician from a long time ago, and his name is pronounced Euler, almost like the word oil. So Euler circuit. Now, what is an Euler circuit? Well, you'll get into the details, but let me just say this. An Euler circuit, the person that came up with is Mr. Euler. An Euler circuit uses every road or connection only one time. So in other words, what we're asking here, does this graph, does it or does it not have an Euler circuit? In other words, is there a way to go, let's start right here, to use every road, every connection only one time? Or if not, are we going to end up doubling some roads? Let's see. Good. Here. Whoop. Oh, and it's a circuit. You got to go back home. Circuit means a circle, right? Circuit is a circle, basically. You got to go back home, return back home where you started. So you've got to return to where you started. That's what a circuit is. So I'm in trouble, aren't I? You see the problem? You think, well, you go there, boom. Yeah, but I didn't cover that road right there. You think, oh, we'll just go back and do it. Boom. There we go. Yeah, well, then I redoubled this road and that road and that road. So I did not cover every road exactly once. So maybe I just did it wrong. Is there a better way? Is there? Can you start here and is there some other way to make it work? Go here, 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 here. See, I'm in trouble again, aren't I? How am I going to get this road without doubling some roads? Doesn't look like it, but how can we be sure? And why in the world do we care? What does this have to do with the real world? Well, actually, this is very useful. Covering every road only one time is very useful for things like street cleaners. What does a street cleaner do? It goes down the roads and it wants to go over every road exactly one time. It doesn't want to redouble its efforts. Or the garbage trucks, they want to go down every road, pick up all the trash, but they don't want to repeat roads. That slows them down. Mail delivery, right? The post office. So all these and many more industries have a desire to take a map and cover that map, cover every road only one time. And sometimes it's not possible. And if it's not possible, they would like to repeat roads the fewest possible times. It's big dollars to them. If you save them a couple of roads every day for the whole year, you've saved them thousands and millions of dollars. This is big dollars to companies in various industries. Euler circuits, ways of hitting every road only one time. And now, one other concept, that's the second concept, and then the third concept is this right here. So this is part two. What we're looking at here is what's called a Hamiltonian circuit. I won't burden you with that name, but what it means is you must hit or visit, let's just say visit every city and the question is, how can you do it as in the cheapest way? How can you do it? How can you do it in the cheapest way? So this is a little different than the last concept. The Euler concept was hit every road. Here I don't want to hit every road. I want to hit every city. So for example, I could start at A, and I've got it. So this would, now who would care about this? This would be a company like Amazon who has to visit, or the UPS, United Parcel Service. They have to fly to several cities to deliver important packages. Well, they want to do it in the cheapest way possible. There's all kinds of ways you could do it. They could go here, then here, then here, then here, then here, then back home. That's one way. But how much would that cost? That road costs 3. This one costs, 7. This one costs 5. This one costs 6. This one costs 4 and back for 14. Add that up. That's the total miles you traveled. But is there a better way? Is there a better way than that? So for example, maybe it would be better to first just go around the outside. That's another way to visit all the cities and come back home, make a circuit. Is that cheaper than the other way? Is there a cheaper way than both of these? Companies like Amazon and UPS who deliver thousands of packages every day. This is big dollars to them to find the cheapest way to visit a bunch of cities. That's different than the last question, which was Euler circuit. Is there a way to go over every road exactly once? That would be for street cleaners and garbage men. But this is for delivering packages like Amazon and UPS. Is there a way to hit every city in the cheapest way possible? And the very first question we answered was, what's the shortest path between 2 points? And that would be useful for other kinds of industries. So here's my second question on the video quiz. And it's going to be, what is Mr. Heron's favorite? Basically, we're going to learn 3 methods. My favorite method is right here. It's called sorted edges. That's my favorite method of trying to find the cheapest way of visiting every city for big companies. sorted edges. That's my favorite method and what I'll ask you about in video question number 2. So that's an overview of what we're going to be doing in this chapter, using graphs to answer practical questions that companies care about. A shortest path between 2 points, an Euler circuit, which goes over every road exactly once, and then a Hamiltonian circuit, another mathematician that came up with a way to visit every city like Amazon or UPS in the cheapest way possible. That's chapter 4.